Okay, everybody, here we are with implicit differentiation lesson 3-4, and we are trying to do 2, 3, and 4 in my break during my training. So here you go. Find the slope of the lines tangent to and normal to the graph of that function at a given point. Oh, yay, he gave us a point. So this is my x value, this is going to be my y value. I'm going to use those values after I find the derivative using implicit differentiation. So following my method, I would say the derivative of x squared is 2x, and I'm going to write down the dx. You'll see me do that. Plus 4y squared, the derivative of 4y squared is 8y. And again, you'll see me write down that I took the derivative, but this time with respect to y. And then the last one, taking the derivative of a constant, is 0. And you could put a dx, but I usually don't. It just helps me remember, hey, did I take the derivative? Yes, I know I did. I got it 0, so I definitely took a derivative. So right here, dx is very boring. It's not very interesting at all, and I like to cross it out after I'm all done taking the derivatives, and now I see that I have a 2x plus a 8y and times dy dx. This is the thing that I am trying to solve for. So if I'm trying to isolate that term, my idea right off the bat is to minus 2x from both sides, to minus 2x from both sides, and then to say that I have 8y, and here's my dy dx, and that equals negative 2x. And now I believe that this is a pretty simple one. All I need to do is do 8y division by 8y, and I now get that dy dx is equal to, and I'm going to go ahead and reduce this fraction right here, negative 2/8. I'm reducing it to negative 1/4. So negative 1/4, and this is an x over a y. Now, at this point, 3, 2, isn't it delightful that I now know what x and what y I specifically am looking for a slope at? So to evaluate dy dx at this point, 3, 2, remember this is my evaluation symbol, says, hey, plug in this x value and this y value, and I'm plugging it in right here with my negative x over 4 times y. There was a 1 right here, and multiplication by 1 is boring, so I'm not going to add that in there. But x is 3 and y is 2. And so now I think I could finally get an answer here, which is negative 3 over 8. Now that's my slope. Okay, when we take the derivative, what is it we're trying to find? We're trying to find the slope. And it said, the question said, can you please find that slope of the lines that would be tangent to and normal to? Now he just said slope. So if I'm just looking for a slope, I have found a slope. This one is the tangent slope. What about the slope of the normal? Remember that it's supposed to be opposite reciprocal, so I'm going to make it, instead of being negative, I'm going to make it positive, and the reciprocal of 3 over 8 is 8 over 3. So those would be the tangent slope and the normal slopes. Now, I wouldn't mind if his question actually asked us to find the equation of the line, because if I have a slope, I could put together an equation. Let's see if we have to do that. All right, let's go ahead and change the nature of this. Find the slope. Okay, good. I did that. Let's call this part A. Now, what about part B? What if I asked you for the equation of the tangent, or the equation of the normal? I would say then that my equation would be, using this point and the point slope formula, I would have my y minus y sub 1, which was 2, and my tangent slope is negative 3 over 8, and this is x minus 3. And what I'm doing here is I'm using this point in this way. There's my 2, and I'm putting it there. And I got this tangent slope, and I'm putting it right there. Okay, now what about the equation of the normal? Well, the normal would be y minus 2 still, and it would still be x minus 3. But the normal slope is 8 over 3, which I'm going to pull from right here. It's my opposite reciprocal slope. So that's how you do that problem.